Hi, welcome to the FreeBSD channel. So there are lots and lots of episodes I have covered about networking and network protocol stacks and network protocol and stuff like that in my other channel, the Linux channel. So I thought today to cover about how do you set up a bridging interface in FreeBSD. This is quite crucial whenever you do some type of network software development, especially when you are building some type of a network virtual driver like ThuntApp. Sometimes you need a bridging interface so that you connect a physical port to one of the interface and you connect a virtual interface in other port of that bridging interface. So this allows us to do a lot of things. And if you think about any virtualization platform like take for instance this Oracle's virtual box, it has a lot of such things happening beneath its architecture. Okay, so if you see that way, in my other channel, the Linux channel, I have covered various video episodes on networking. As you can see here, recently I have covered a video episode on OSI model where it where these rules are getting broken in the case of tunneling and other stuff. So these are generic networking videos. In case if you are really interested about the same, you can watch these videos, because it is nothing to do much with any specific operating system. So as a example standpoint, I must have done in Linux, but at the same time you can recreate these things in FreeBSD as well. So similarly, if you see recently I have covered a video episode on networking layer 2, layer 3 and stuff. So if you are very much into network software development, or if you are a network admin, but still if you are interested about various internals in networking, you can go through these videos. So we hop on to this FreeBSD context. You can see here I was covering exclusive video episodes on FreeBSD networking subsystem. So I have covered so far 3 episodes. A couple of them shot quite long back, and this episode I have covered quite recently. In this I am discussing about the IPv4 stack. So as an upcoming series of that playlist, I may cover about the layer 2 stack of FreeBSD kernel as well, so that it gives a picture that when you do some bridging of these network frames or packets, okay, it will pass through that layer 2 context. So in the case of Linux, what happens is, if the packets are meant for local system, or if the packets are getting routed, you get these packets going through net IPv4 modules. So in the case of in a Linux system, if you configure it as a layer 2 bridge, okay, you configure via brctl command, whereas in the case of FreeBSD it is quite different. So if you configure, it will bypass this IPv4 stack, and it goes all the way the packets will come from device drivers, and it goes through core module, and from there it gets into the bridging stack net bridge folder, and from there it gets forwarded like any other bridged packets, or else it gets switched. Okay, layer 2 switching happens over there. So in the case of FreeBSD, we can explore the stack as well in the upcoming episode of FreeBSD networking subsystem. But this episode we discuss about how you can set up a layer 2 bridge. It can be useful if you are a sysadmin, or it will be useful even if you are a developer. But if you want to do some type of core network software development, this may be quite useful. So before that, we can just very quickly hop on to this FreeBSD series, because if you are into development, okay, you can later go through this networking subsystem. I have done some sort of a flow diagram of this various APIs, and since we can take a Linux kernel as a reference, I have done the same. So you can see here I have done about v4 part, IPv4 stack, I may add the bridging components as well, so that we can have 1:1 comparison between the Linux files and the module names versus FreeBSD files and module names. So this is something I thought of adding on to this video, so that it will be helpful if you are into some type of kernel or network software development. It may not be that interesting for a sysadmin. Okay, so we just hop on to this setting up a bridging part. So you can see here they have done an extensive documentation in official FreeBSD documentation guide. So here, if you go here, they have provided all the steps. So we try to iterate the steps, at the same time we can see how it works in the real time. Okay, so what I have done is, in my system, it's a Ubuntu host, and I have various VMs configured in this virtual box, so that it packs my entire lab into this virtual box system, so that I can do any type of complex networking part, and I can have as many as servers as well as systems based on its system resource limitation, whatever it is. So what I have done is, I'm running this FreeBSD based pfSense router. So this router will be acting like an internal network, so that we will get the network within that VM. So you can see here it has one port that side, which is connected to the NAT interface. This NAT interface will be connected somehow via virtual box virtualization automation. So it will be connected eventually to the Ubuntu host machine, and from there it gets that internet access. Okay, so the other side, it has this internal network, and from there it provides that is its LAN interface, and it provides the DHCP address range and stuff. So it provides a DHCP address range around 8 subnet. You can see here 192.168.8.1. so it gives in this subnet range. So I just configured in that way. So you have a full-fledged router, and what we can do is we can fire up this FreeBSD server. So this FreeBSD server is actually, I'm using it for some type of build system, so that I can build applications, an entire C or C++ compiled applications, and I can use them on my FreeNAS production FreeNAS server over here. So I can use the same. It will be quite useful, because you can't compile on a production server, so that you can do your applications here. If there are some scripting applications, it is fine, but if you want to go further one step ahead and you want to write directly C or C++ files, applications, okay, then you need some type of a build system. So this is my build system for this production server. So you can see here it has two ports. One is in this iNet, and the other one is this iNet2. What we can do is we can fire up this server. So let's just quickly fire this server. So it has some type of dual desktop environment I just configured, so that I can do some type of I can run some type of GUI applications and stuff. But other than that, if not a server, I sometimes do use it as a test FreeBSD system. Okay, so yeah, as you can see, it has booted up, so we can just log in. Yeah, you can see it has logged in, and if you do ifconfig, you can see it has two interfaces. One is in this one got the network address, IPv4 address. You can see here it is 192.168.8.150. so this is provided by the pfSense router, as I showed earlier. So this is given by pfSense router. So this is connected to that port. The other port is connected to another virtual network. So that network we can connect a desktop, and we make this as a bridge, so that we see that layer 2 bridging happens. Please note, we are not doing any routing here. We are trying to configure this as a pure layer 2 forwarding engine, so that we get this frames getting forwarded. Okay. So next what we do is we fire up this desktop. So this desktop, you can see here, I have connected to this internal network 2. So this internal network 2 is the other port of that FreeBSD server. So you can see here. So this is a regular Ubuntu desktop. So let's just boot the same. So this will not able to get any connectivity because it is connected to an internal network where that internal network doesn't have any DHCP server, or if it has its own IP address configured statically. Okay, so let it boot. Yeah, you can see it is just about to get this interface. So let me go inside. And I can show you if I enable the network, it will, it will try to connect, but it won't get any IPv4 address. Okay, so you can see here it is trying to connect, and we can open this terminal. And if I do ifconfig, you can see technically it should not get any IP address because it is not connected to any router or anything. It is just link is up, but it is not getting any IPv4 address, and nor we have configured any static IP to that port. Okay, so it will try to get the same. It will remain forever like that unless until we make this FreeBSD as a layer 2 forwarding device. Okay, so you go back to this instructions. It is quite clear. If config bridge create, so we try to do the same command. So as I said, this is quite different in Linux. You use a tool called bridge control. You use that user space tool called bridge control, and that internally communicates with the kernel. I think it is via IO control APIs or something like that, and then it activates that bridging stack, and then it does that. Okay, so I need to still explore in the case of FreeBSD how these things happens. Okay, so we do the same. If config bridge create. Yeah, you can see here it has just created a virtual bridging interface. So we do an if config. You can see here it stays as bridge 0. So currently it doesn't have any interfaces attached, so it is going to be independent, and you still able to get that EM0 and EM1 interfaces. So next what we do is we add or attach this interfaces. So you can see here the instruction they have provided as if config bridge 0 add module. They are just calling us not module, members. They are calling us members. So each of this is like a specific interface connected to that bridging port. So in the physical world you can see a bridge containing Ethernet port. So same way we are connecting these ports to that bridge. So you connect just couple of ports, then it is a switch with 2 ports. If you are connecting more ports, then it's a switch with number of additional ports. It is going to support. So it is like that. Since it is virtual, we are building everything step by step, unlike any ready to use switch as you get it ready to use hardware. Okay, so we do the same. Okay, if config bridge 0 add module, if config bridge 0 add module EM0 add module EM1. So we provide the same, and if you do once again if config, you can see here these two members are added. I'm sorry, I'm not supposed to call it as module, it is called as a member. So I try to get used with this nomenclature. So you can see here these 2 members are added to the same, and what we can do is we try to test the bridging interface. But before that, like even in Linux, we need to enable this interface up. So we need to do this if config bridge 0 up. You can see it doesn't have any status, so we need to enable the same, and we do if config. Yeah, you can see its status is up, and now we go here and we try to reconnect this port. Okay, if the bridging works effectively, this should able to work because it is connected to that interface of that bridging port. So it is still not getting any connectivity. So we try to debug the same. There are things sometimes it can be an issue in the VM setup, or in case if you are using direct hardware, sometimes you may have any loose cables or anything. It may have pin getting oxidized and stuff like that. So these things are quite common, because sometimes you do this type of building an appliance, network appliance with a consumer grade hardware. You are not getting any type of ready to use hardware and doing the same. So sometimes you need to tackle the same. Sometimes there may be issues in Ethernet cable crimping, so you can find a lot of such issues in using a real hardware. Whereas in the case of VM setup, sometimes you need to check your VM setup itself. You must have done some mistake, or sometimes there may be a bug in the VM system as well. So let's just debug the same, so that we find out why it is not able to get this interface. Okay, interface IP. So we go back here, you can see the desktop is connected to internet network 2, and this is like this, and the FreeBSD one is at this interface, the other one is internet network 2. So we can do one thing as an optional step. We can also do, like they mentioned, we can also provide an interface address to our bridging interface. This is also possible in Linux system as well. Sometimes you may need to do, so that you can able to reach that device without any additional management ports. Sometimes if you have an additional management port, then you can exclude this step. In my case, if I use it for my toffee or anything, I generally don't tend to do this. Okay, so we try to configure this port if config bridge inet, and we can provide its IP address. So if config bridge 0 inet, and we try to provide it in this subnet 8 dot, say for instance 22, and its subnet mask is 24 bits. So we try to provide the same, and if you do if config, you can see here it has this IP address enabled over here. So we try to ping to this its gateway, which is connected 192.168.8.1. yeah, you can see it has this connectivity, and if you do if config em1, effectively its v4 address should vanish. So you can see here earlier it had this v4 address, now it no longer has that v4 address, because it is connected to this bridge interface as one among its members. Okay, so you can see here it is connected here, and yeah, it has this interface. So now we need to explore. We just try to redo the same. Is it something I'm missing? Let us see. Yes, if you want, you can enable this STP protocol, and this is something required if you have a lot of switches connected in your network, to avoid any loops, and also to avoid effectively broadcast ROMs of frames going across these switches. By mistake you may configure them in a sort of a ring like pattern, and then in case if there is any broadcast sent, and in case if there is any packet arrays, then it may try to loop around, and then it will stay forever. Okay, so STP you can enable if you want. So it is fine, it looks like it is okay. So I'm not sure why it is still unable to connect to the same. Let me just check what is its port is. Internet 2. This is also Internet 2. So technically it should work. I'm not sure. So maybe let me just try to restart or something, or cancel. Let me just shut down. I'm not sure, because this is something I'm not sure. It can be a VM issue. So we can also try to debug how we can solve this situation. So yeah, it is powered down. Let me just turn it on back, and we see what happens this time. So in this case, the bridge setup is already up, so there is nothing else we need to do in that case. So we see once it boots up, okay, if it able to connect this point of time. Okay, Yeah, as you can see, it is just booted up. Okay, we try to redo the same and we see if it fixes this problem. Okay, since it's a VM, I am doing this type of steps. If it is something directly attached a physical system, then I must have checked the cables and the NIC card status and stuff like that. Okay, so yeah, it is the same situation. It is not up, but what is that I have noticed is you can see here they are providing this if config that hardware interface up as well. So it looks like maybe it is down after it is added as a member to that bridging interface. So what we do is we just try to do the same and we see if it fixes this problem. Okay, so if config em0 up, and if config we can also check em1. Yes, its status is not up. You can see here its status is not up. I think this is the issue. So em1 up, we do the same and we see if config and if config grep up. So we see if everything is up. Yeah, you can see the port is up, the ports are up, both the ports and as well as this virtual bridging interface. So everything is up. So we see if this fixes this issue. So let me disconnect and reconnect. So it is still not getting connected, and what I find suspicious is there is something like you need to explicitly enable promiscuous mode in the in the virtual box. I think I'm missing the same, so I think this is the issue. It is not turned up. See, one thing is I can do some sort of rehearsal before doing this video, but most of the times I don't do the same, so that I try to capture as much possible whatever I face issues, so that it gives that clear picture in case whatever I showed, the demo may be working, but if you try to recreate in your home lab or in your office, you may find some issues. So you can see here clearly the promiscuous mode is disabled. So obviously what is happening is the NIC card, the virtual NIC card, it is just dropping the packets if it is some type of unicast packets which is not matching to that NIC card address. So this is the reason it is not properly working. So it is quite obvious we need to shut down that our FreeBSD server and we need to enable the same. So which effectively means history. What we can do is we can just store this history, history.txt. So ls cat history.txt, so that we can try to recreate this once it is turned up once again. Okay, so we just try to shut down this device, shut down now, something like that. So we try to shut down the same and then we enable the promiscuous mode. So if you are new to networking, promiscuous mode allows you to get any unicast packets. Once it touches the NIC card, it will be pulled all the way to the software layer or your operating system. So this is something I have even discussed about it in this video as well. Okay, networking in layer 2 and layer 3, unicast, multicast and broadcast packets and frames. Okay, so whenever you talk about L2 context, you call them as frames. Whenever you talk about let me just do a quick power off. When you talk about L3 context, you call them as packets. So we try to enable this promiscuous mode, allow all, and settings, network, advanced. So here it is enabled, and even here the other port we try to enable the same. So we just start the system. So let me just do a very quick check before I do that. So this port is enabled, this port is also enabled. We just try to start the same. Yep. See, one thing, if you're into networking, if you're a beginner, this is for you. Okay, so that while it boots up, I thought to discuss something. So if you're very new to networking, one thing is 90% of the times you try to configure something, it may not work. This is something so common if you're a sysadmin or else if you're a developer as well, because I have been both sysadmin initially for a few months and as well as a developer after I got a job as a full-time programmer or a systems programmer. So one thing is, whenever you try to set up anything in terms of network configuration, let it be in the virtual stuff or else in the physical world, always you may have certain issues. So you need to understand, then you do steps and recreate and doing a setup. Most of the times you should have more skills about how do you debug a particular problem. Likewise, you've seen in my case, I was missing that VM setup. So this may not be an issue if you do a physical bridging with the physical devices, but if you do in a VM setup like mine, then it may be an issue. Okay, so you can see it is booted up. Okay, so let me just go inside. So cat history.txt, all we need to do is we just need to retype those commands. Okay, so if config create bridge create, and if config bridge 0 add member em0 add member em1. So even we have done that. Then if config bridge 0 up, if config em0 up, if config em1 up. So we have done everything. So we can even do this optional if config bridge 0 inet 192.168.8.22/24. okay, then if config, you can see here it is up and it has all this member ports. Okay, we can do a quick check grep and up in caps. So we can see all the ports are up. So this confirms it is finally turned up. Now we can go back to this desktop and we can check connecting to the same. Yes. So you can see finally it is connected. So as you can see here, first I did a mistake by not enabling those member ports. So that is something I have debugged, and then I have discovered I'm missing this step what they provided already in this official documentation. The next you can see it is purely something a VM issue, because I need to enable promiscuous mode. Anytime you need any network appliance, you need to enable the promiscuous mode in this kind of a scenario. This is something VM is abstracting. This is not something you are going to get an issue in a real system, because it is going to turn up promiscuous mode already inside. Okay, so if you see here, it is already turned up in the software layer, but VM is not enabling in the NIC card level, which means it has this virtual firmware of that NIC card, which VirtualBox is providing. Okay, that virtualization aspect, it is not enabling that promiscuous mode. Please note, when you tell promiscuous mode, the promiscuous mode configuration or the parameter goes to the NIC card. The hardware in the NIC card enables that. Okay, it is something a hardware does. Okay, there is no control for the software or the operating system. When you tell enable promiscuous mode, the software just tells the NIC card to just enable this promiscuous mode. So there is no control an operating system have in terms of promiscuous mode. The NIC card, it is up to the NIC card to enable the same. So this is what. So in this case, although the software have done promiscuous mode, it is not actually enabled in the NIC card. So since it's a virtualization setup, it is not possible unless until you go there and you do this in VirtualBox VM config. So this is what. So as you can see, it has got this connection, and we can do if config. You can see here it has got this IP through DHCP from that pfSense router, and you can access any internet. Okay, so we try to ping 192.168.0.88, that is my Ubuntu host, and even you can ping 0.1, that is my home router, and you can ping to this Google DNS server. Okay, yep, so we can reach internet. Okay, so this is what. So this way you can configure your FreeBSD in bridging mode, as I said, it is quite useful when you are doing a real work on some type of network appliance. Sometimes especially you need to create some type of virtual network ports. Okay, whenever you create a virtual network port, it will trigger some type of virtualization platform like a driver. It will be a virtual driver acting like a physical port, but internally it does some type of packet manipulation. Okay, so that's what. So it depends on what you are essentially trying to achieve. If you use StunTap, it is meant for some other purposes. If you use some other platform, it is meant for something else. So this is what it is. So this way you can set up a bridging stuff in FreeBSD. This is all happens in the kernel part. Essentially this is something happens in the kernel layer. So this is what is the case in Linux as well. In FreeBSD as well it happens the same. So sometime down the line, like I said before, I may discuss about this stack in my FreeBSD channel as a part of networking subsystem episodes. Okay, so I have the entire FreeBSD source. You can see here I was discussing about this V4 IPv4 network stack, and somewhere in the sys folder, it is actually inside the sys folder. So I need this to go back. So if I go to the code and FreeBSD sources, and if you go back a bit, you can see here I'm inside the FreeBSD sources, and if I go back a bit, you can see here user src sysnet. Somewhere you may find the bridging modules. Okay, so I need to trace the same so that it will be a very interesting episode. It will be quite useful if you are into network software development. You can also insert some inject some additional code here, and then you can manipulate this bridging frames the way you want. Okay, sometimes I do quite often directly I inject the code rather than writing any sort of modules, kernel modules, so that I will get that superior control over these network packets or network frames, whichever context you want to grasp that finer control. So with this, I would like to conclude this episode. Hope you guys loved watching the same. If you like this video, please hit the like button. So if you have anything to discuss, be in touch via mail or YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.